How does a complex system fail? Our intuition tells us to look for a sudden break, but what if failure is a much slower process? A gradual dimming of the lights until the system can no longer see itself. This is the structure of systemic blindness.
Our intuition expects that when a system breaks down, it's going to be a clear, identifiable moment in time.
We look for a single cause, a specific component that fractures, or a single decision that goes wrong. We see failure as this sharp, sudden deviation from normal operation.
But there is another path to failure. It's one that doesn't involve a sudden break at all. It's a much slower and far more subtle process.
This is a failure of perception. The system gradually loses the ability to accurately observe its own performance, becoming blind to its own emerging problems. To understand this, we first have to understand how a system sees.
So, to understand how a system goes blind, we first need to get a handle on how it sees. Every complex system, it doesn't matter what domain it's in, has some kind of mechanism for self-observation.
For our purposes, we can think of any complex system as a kind of black box. Its internal workings are mostly opaque. We can't know everything that's happening inside. All we can really see are its inputs and its outputs.
Given that, we can really break this system down into two fundamental parts. First, there's the core process. That's the part that does the actual work. And then there's the observation layer, the part that measures the inputs and outputs of that work.
Now, this layer is absolutely crucial. It's the system's eyes and ears. It collects all the data and the metrics that tell the system how it's performing, allowing it to adjust and correct its own course. But what happens when those very senses begin to fail?
This brings us to the first major mechanism of blindness, the measurement trap. This is the point where the very act of observing performance starts to corrupt the system's perception of reality. At the heart of this trap is something called the performance paradox. And the idea is that any useful performance measure will, over time, degrade in quality. And it degrades precisely because it's being used as a measure. Its connection to true performance just gets weaker and weaker.
This happens through a four-step sequence known as the running down process. First, a new, useful performance measure gets introduced. Second, people inside the system learn how to optimize their behavior to make that measure look good. Third, and this is the key step, the measure stops being a signal to learn from and becomes a target to be achieved. The goal shifts from improving the real process to just improving the metric. And finally, the link between that metric and actual performance erodes, sometimes to the point of being completely meaningless.
As its key metrics get disconnected from reality, the system's ability to see itself clearly starts to degrade. The data is still coming in, sure, but it no longer reflects the truth of how the system is actually operating. The system's response to these blurring metrics often just makes the problem worse. In an attempt to get some clarity back, it creates a brand new problem. It drowns the original signal in a sea of noise. This leads directly to a state of information overload. As the old metrics decay, new ones get added. But here's the thing, the old ones are rarely removed, so the system just accumulates layers and layers of measurement, creating this dense fog of data that makes effective decision-making nearly impossible. Initially, the system might have had one primary high-quality signal. Performance was easy to read, the data was clear, and it was directly related to the core process. But over time, that single clear signal is joined by countless others, some of them old and decayed, some new and uncorrelated. The critical data, the stuff that really matters, gets hidden in all that noise. The system is measuring everything, but it's seeing nothing of importance. So, with its senses already compromised, the system becomes vulnerable to the second major mechanism of blindness. It begins to accept lower and lower standards of performance, often without even realizing it's happening. This process is called the normalization of deviance. It's when a behavior that deviates from the correct official standard gradually becomes the new accepted norm. Let's imagine a system where, at the very beginning, the official standard procedure and the actual practice on the ground are identical. The system is operating exactly as it was designed. Now, a small deviation from that standard happens, maybe a shortcut or a workaround, but because the system's senses are already blurred by bad data and information overload, it doesn't register a negative consequence. The flawed metrics show that everything is still looking fine.
Over time, because no catastrophe happened, this deviation is accepted. It becomes the new baseline. The system has effectively updated its definition of normal to include the lower-performing, deviant behavior. The standard has eroded.
Now, when we combine these mechanisms, we can start to see how the final state of systemic blindness emerges. The system has lost its ability to see its problems, and because of that, it's lost its ability to correct them.
You end up with a recipe for blindness. The system is operating on flawed data because of the measurement trap. It can't identify critical signals because of information overload, and it has accepted a degraded state as the new normal.
In this state, the system's ability to learn becomes fundamentally constrained. It can still perform what's known as single-loop learning, which is asking, are we doing things right, and then making corrections within its existing rules. But it has lost the capacity for double-loop learning, the ability to ask, are we doing the right things? It can no longer question the validity of its own rules and assumptions.
Blindness, then, is not a sudden event. It's not the result of a single mistake. It is an emergent property, an unintended consequence that arises from the system's own structure and from the rational, local decisions made within it. The failure wasn't a break in the system, but a product of the system.